This is Math 1316. Trigonometry, we're dealing with Chapter 7, Section 5. We're looking at vectors. I'm David Dipple from Lone Star College, Montgomery. Okay, definition of a vector is a directed line segment. So you start at a point called the initial point and end at a point which is the terminal point, and it has a direction. So it goes from the initial to the terminal. So in this case we're starting and we're stopping, and there is a specific direction that we're going. It's like a train. It starts and it stops. It goes from the initial to the terminal. If you're going from Houston to Dallas or wherever, if you start in Houston, go to Dallas, that has a direction. Notation, we usually use lowercase, or we can put little arrows over them to notate vectors. So suppose we have the letter U, it's lowercase, has a little arrow over it, means it's a vector. We usually put braces around it, so it's 1, 3, and then -2, 1, and 2, -3. Now these vectors, since they don't give you a starting point, start at 0. So we're going to start at 0 and go to 1, 3. So we start at 0, 0, and go over 1, up 3, and that's our ending point, and so our arrow goes from 0 up to 1, 3. -2, 1 goes from 0, find your point, -2, 1, so your vector goes from 0, 0 over to -2, up 1. 2, -3 means you're going to go 2 right, down 3, and when you get there, the vector goes from 0, 0 to -3. Okay, the length of a vector, how long it is, the distance that it travels, is called a norm or a magnitude, and the notation for that is a double absolute value, and the formula is essentially absolute value, which is the square root of the x term squared plus the y term squared, and that will give you the distance or the magnitude, the norm of the vector. Okay, you can add and subtract vectors. If they're in component form, which is what we looked at before, if they look like a point, you can just add and subtract the components. For instance, if you have 5, 2, and 8, -4, you can add these vectors together by adding the 5 and the 8 and the 2 and the -4. 5 plus 8, 2 plus -4, which makes 13, -2. You can subtract the vectors. Make sure you subtract a negative when you're doing the -4. So it's 5 minus 8, 2 minus -4, which makes -3, 6. So make sure you distribute the negative to the 4 if that's what you're subtracting. Okay, we can multiply by a number. That's called a scalar. You're scaling it up, you're making it larger. So if you multiply by 2, it'll be twice as large. And you multiply each of the components. So if you have 5, 2, and you want to multiply by a scalar like 6, that's going to be 6 times as large. You've taken a vector and you've stretched it out 6 times as large, which makes the point move to 6 times 5 and 6 times 2, which is 30, 12. That's scaling up a vector. Okay, now just some quick examples to remind you what to do. Suppose you have U is 5, 3, V is 2, 4, and W is -3, 5. The norm of W, that's when you take the square root of 3 squared and 5 squared, which makes 34. That's 9 and 25. Okay, the norm of V, that's the square root of 2 squared plus 4 squared, which is 4 plus 16, makes a square root of 20. You can simplify that as 2 square roots of 5 if you like. If you're adding the vectors together, I'm adding U and W. So if I take 5 and -3, 3, and 5, which makes 2, 8. If I subtract V minus W, 2 minus -3, 4 minus 5, gives me 5, -1. And then if I multiply by the scalar 4 times the U vector, 4 times 5 and 4 times 3, which makes 20, 12. So those are the operations we deal with vectors. We can add, subtract, multiply by a scalar. and find the norm or the magnitude, how long the vector is. So that's the operations we're going to be dealing with vectors in section 5. Okay, this is 1316 trigonometry. We're working in chapter 7, section 4. We're looking at the triangle area formulas. These will work with all triangles. It's just not 1/2 based on its height. There's a lot of different triangles where you don't have a base and a height, and these come in handy. I'm David Dipple from Lone Star College, Montgomery. Okay, if you have a side, an angle, and a side, you can use the S is our area, is 1/2. You multiply the two sides together, and you take the sine of the angle that is in between the two sides. And you can pick any order. You can do B and C sine A and B sine C. But it's two sides multiplied together times the sine of the angle that's in between them. Okay, if you have two angles and a side not in between them, then the formula is A squared, if A is your side, sine of B sine of C divided by 2 sine of A. And again, you're going to have two angles, so once you have two angles, you can find the third, so all the angles are known, and the side is known, and you can just type the numbers in. If you know a side and two angles, okay, you can rearrange that. Now you'll notice if A is the side, the angle goes on the bottom. If B is the side, angle B goes on the bottom. And if C is the side, angle C goes on the bottom. And then if you have three sides, the formula gets a little more complicated. What you do is add the sides together and cut it in half. So your three sides sum, cut that number in half, and we call that little s. That's the sum, basically, of the sides, except it's slightly altered. It's not just the sum, it's half of the sum. Then the actual area is the square root of this number that you just summed, cut it in half, times that number, subtract side A, times subtract side B, and times subtract side C. So if you have three sides, you sum the sides, cut it in half, and that's a number we're going to be dealing with. We call it little s. And then the square root of little s times little s minus each of the sides will give you the area. Okay, suppose we have an angle and two sides. Okay, if you go through and look at your formulas, the one that has one angle and two sides that are beside the angle is this one. So you're going to use 1/2, multiply the two sides, sine of the angle. And when you do that, you should come out with 2.49. Okay, the second one, I would convert the 2410 to degrees, the 12040 minutes to degrees. Find the third angle, because you have three angles this time. So we're using this second one on the page we did earlier, the one with three angles in it. And so you'll take A squared, your side squared, sine of the B angle, sine of the C angle, that's the one that you had to figure out, divided by 2 sine of the A angle. And when you do that, you should get 10.9. Okay, number 3, we have three sides, so we have to figure out what is C. Not C, excuse me, S. S is the sum, 12 plus 14 plus 8 divided by 2. And I came up with 17. And then you take the square root of 17, 17 minus 12, 17 minus 14, and 17 minus 8. And again, S I came up with 17, and my area I came up with 48. Okay, then we can do the same thing at the bottom. If I give you A is 32 degrees, B is 70 degrees, and little a is 3.8. Okay, you're given two angles. So you can plug in this information. If B should be 6.7. Okay, so for number 4, using law of sines, you come up with 6.7. Number 5, with the law of sines, you should get A is 26.5 and B is 38.3. And then number 6, law of cosines. If you have a 60, an A and a B, you should get no triangle. Sorry, law of sines. There's no triangle on that one. So that is everything from section 4, mainly finding the areas and then this review material.